Analyzers. Welcome to Chapter 7, Lesson 8, where we are going to solve exponential equations again, but this time we're going to use our logarithms to do it. So back in Lesson 3, we had solved exponential equations, and what we did was these were exponential equations where, we could make the bases the same number. Well, let's kind of review those first, and then we'll get into what if we can't make them the same number, right? So, if we have the same base, then obviously the exponents are the same, right? So like here, we have the same base. So really, since x is in the exponents, all you have to do is say, well, then these two things must be equal to each other. These two exponents must be the same. So we get all the x's on one side of the equal sign, all the numbers on the other side of the equal sign, and we get that x equals 3. Over here, 25 can be a base of 5 because 5 squared is equal to 25, right? So I'm going to take this 5 squared and substitute it in for 25 here. So now I've got this base of 5 all ready and waiting to go. Now this is a base of 5, but it's 5 squared. And then you multiply that number by the exponent that was already present. So really, these two exponents are the same. 2 times 2x being 4x. Subtract that 3x over, you get negative 8 equals x. That's what we did back in lesson 3. Well, now, what if we have 5 to the x power equals 7? I'm not thinking of any integers that both of those could be for the same base. So when that's the case, when you've got something like this, remember that exponents can be converted into logarithmic form. Since I'm not thinking of any integers that both of these can have the same base of, then if I convert this into exponential form, I don't need to do that. So actually, I could have done this with the other ones too, but it was easier to think of them as being the same base. Now it's not easy to think of something that both of these can be. So instead, I'll convert into logarithmic form. Now notice only one of these has an exponent, okay? So that's what is going to make it easier to convert this into logarithmic form, right? Here's base of my log, 5. Here's the answer, and here's the exponent, which is the answer to the log. So notice I've isolated x, right? I got x alone. Now I just need to solve whatever's going on here. And since those are two, that's an answer in a base that there is no integer that those are equivalent to, I'll use my change of base formula, which is log base 10 of 7 divided by log base 10 of 5, to be able to plug that into my graphing calculator. Okay, so let me pull my graphing calculator out. And again, notice I've got that variable alone already in doing this. All I have to do now is round to the nearest thousandth. So 3 decimal places for rounding. So this would be x is approximately 1.209. And that makes sense because what we're saying is our exponent on 5 is 1.209 to get 7 as an answer. Okay. And so I'm just going to show you how close that approximation gets you if I put 1.209 in the exponent for 5. And that's how close that approximation gets you. Obviously, I would need the entire decimal, but since it's a non-repeating, non-terminating decimal, I'll take the 10,000ths, the thousandths, which then converts into 7, rounds up to 7. Okay. Again, like I did before when we were solving exponential equations, we've got the answers right here. Okay, so the exact same thing I was just doing there. This is why logs are so handy. It really is. This is why logs are so handy when it comes to looking at them through the exponent lens. Not every exponent is an integer. Not every exponent is an easy to deal with rational number that we can convert into a radical and then deal. Some of these are going to be non-repeating, non-terminating decimals, and that's what we're trying to work with. Continuing. I know we want it to be the case. But 3 squared is 9 and 3 cubed is 27. So I'm not going to be raising 3 to some integer power to get 15, which also means that 15 can't then convert down to be a base of 3 in an easy fashion. Now, again, my exponent has the x in it. So if what I just do is say, okay, let's just convert all this into logarithmic form, we've got log base 3 to 15, which is the answer over here, equals my exponent. I've at least consolidated the x off to one side of the equal sign, and I can deal with what's going on with the log over here. I can convert it using log change of base formula. So now these both have a base 10, and I can easily type that into my graphing calculator. And now actually, I'm just going to solve the rest of this by typing into my graphing calculator. So what I'm going to do is, and again, I'll expand so you can see my graphing calculator screen nice and big. I'm going to do log of 15 divided by log of 3 to get this non-repeating, non-terminating decimal. Then, since this, and I'm just writing it down what I see on the screen, so I have something to work with as I type into my graphing calculator to get x alone. What am I doing to get x alone first? I'm subtracting 1 from both sides. So let's subtract 1 from this value. Okay, so then this is what comes down to the next line. I mean, obviously, we all could have done that in our heads, but it'll get more complicated here because now you've subtracted 1 from both sides. Now we need to divide both sides by 2 to get x alone. So just take this answer and divide it by 2. There you are. X is approximately, and again, we round, let's round to the nearest thousandth. So that's 3 decimal places. I know I have 4 on here, but let me just show you that difference. Would be 0.732. Okay. And again, that's just the easy, nice, easy conversion, right? Nice, easy conversion. And then we can just use our graphing calculator to finish the solving, the getting x alone. Okay, when you can't get that same base with these exponential equations. E just means when you convert into log form, you use ln, which there's an ln button on your graphing calculator, so you don't even need to worry about that. E means log base E is written as ln, and then I don't have to write the word log, and I don't have to write that base E, equals, 30 of 30, ln of 30 equals my exponent, which is x. So actually, this is the easiest one of all. I just type in ln 30, and I get this, and we'll round to the nearest thousandth. So what that's x is approximately, 3.401. There we are. That's it. Okay. If you run into a situation like this, okay, so exercise 5 down here, don't forget your exponents rules. Okay, don't forget your exponents rules. Your exponents rules here are saying, well, this is the same base. So all you need to do is actually subtract those exponents. So I can write this as 1 base with my exponents subtracting. That's it. Now it's equal to 30, right? And this just goes back to what we were doing before. Okay, well then that's log base 2 to 30 equals x minus 3. So we'll convert log 30 divided by log 2. And now we'll use our graphing calculator to do the rest. So log 30 divided by log 2 gives me this. Now to get x alone, I add 3 to both sides. So just add 3 to both sides and boom, there you are. And we'll round to the nearest thousandth, approximately. Because I added 3 to both sides, so I get 7.907. There you are. So if you run into a situation like this, where you've got like bases, they're being divided, which just means their exponents subtract. If they were being multiplied, if those like bases were being multiplied, their exponents would have added. When you've got that like base, you can use those exponents and logarithmic rules to your advantage. And that's exactly what we just did right here. We used that rule to our advantage. Okay. So that's the reason that we have these things in place. So we can start solving these more complicated equations, both exponential and logarithmic in nature. So this time when you go and practice, I want you to practice with the mindset of changing the exponents into logarithmic form. So you don't have to get like bases. You just have to convert your exponential form into logarithmic form and then use the change of base formula. You're going to be required to write out your change of base formula on your test. So this is a great place to practice that again. Okay. And so that's why I keep writing that change of base formula out for each of these. LN doesn't require that because you've already got your base of E, right? Which is one of our buttons. So here, right, writing my change of base formula out to then type it into my graphing calculator. Okay. I've been rounding to the nearest thousandth. I think that or 10,000th, which is 4 decimal places, is what I did on your homework, but just follow the directions on your homework for rounding. If I didn't put directions, pick thousandth or 10,000th, so 3 or 4 decimal places, and just round correctly. We've got the answers in our answer key. Okay. Let me know if you need anything. Good luck, guys. Have fun with this new version of exponential equations, right? Using logarithms instead of change the bases to be the same. A nice new way to look at them. Good luck. Have fun. I'll be seeing you. Bye, guys.